All right, guys, so today is day 2 on triangle congruences, and we're going to go over the 5 different theorems we could use. A lot of people call them shortcuts, and they really are shortcuts. I just don't like the word shortcut, so I'm not going to use that word. But they do. They make your life a whole lot easier. So before now, in order to prove 2 triangles are congruent, we'd have to show that all 3 sides of one triangle are congruent to all 3 sides of the other. And then would also have to show that all 3 angles of one triangle are congruent to all 3 angles of the other. So we'd have to know 6 pieces of information, the 3 sides and the 3 angles. Now each of these cuts it down into knowing only 3 parts of the triangle are congruent, and one is 2, kind of 3. So you don't have to show, if you use these theorems, you don't have to show that every single part of both triangles are congruent. Okay, so here's the first one. It's side, side, side. So under the side, side, side flap, if you open it up, you will get this. That's kind of the way I've set this up. And this theorem tells us that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay, so get out your highlighters if you have them. I'm going to be highlighting a lot of mine. So what this tells us is if I know that AC and DF are congruent, and if I know that BC and EF are congruent, and if I know that BA and ED are congruent, that's all I would need to say that the triangles are congruent. So I could say if BA is congruent to ED, and BC is congruent to EF, and then AC is congruent to DF, I could say then triangle BAC is congruent to triangle EDF, and that would be it. I don't need to know anything about the angles. So all I need to know is the 3 sides of one are congruent to the 3 sides of the other. I don't need to know anything about the angle, and according to this theorem, or using this theorem, I could tell you these triangles are congruent. All right, let's look at this one, the side angle side congruence theorem, or usually it's just SAS. Okay, now I want you to notice that the A is between the 2 S's, okay? Or I could say the angle, because that's what it stands for, is between the 2 sides, okay? So that tells me that if I know, I don't know, say angle A is congruent to angle D, and if I know that AC is congruent to DF, and then BA is congruent to ED, then I can say the triangles are congruent. So I could say if BA is congruent to ED, angle A is congruent to angle D, and then AC is congruent to DF, then triangle BAC is congruent to triangle EDF. I would not need to know anything about the other sides or anything about the other angles. All right, so the angle side angle theorem, and now notice the side is between the 2 angles. Okay, so the side has to be between the 2 angles here. So let's say angle B and angle E are the same, and then C and F are the same, and I know the side between those angles. So the side between B and C would be side BC, the side between E and F would be E and F. So I could say here, if angle B is congruent to angle E, and BC is congruent to EF, and angle C is congruent to angle F, then I can conclude triangle ABC is congruent to triangle DEF. I would not need to know anything about the unhighlighted areas. All right. Now our next theorem is angle, angle, side. Now notice the known side is not between the two congruent angles. Okay, so let's suppose I have this angle here and this angle here. We know those are congruent. Say we know this angle and this angle are congruent. And the side that is congruent is not between these. So it could either be BC and EF, or it could be BA and ED. It doesn't matter. I'm just going to put BC and EF. Okay, so I can say if angle A is congruent to angle D, angle C is congruent to angle F, and BC is congruent to EF, in parentheses I can put or AB is congruent to DE. Either one of those would work because those sides are not between the two angles. Then triangle BAC is congruent to triangle EDF. All right, the hypotenuse leg congruence theorem. Now, I do want to warn you that this is often forgotten about. Okay, this is the theorem everyone seems to forget, and I think it's because all the other ones have angles and sides in it. This isn't an angle and a side, this is a hypotenuse and a leg, which really are two sides. And remember, the definition of a hypotenuse is the side opposite of a right triangle, of a right angle, in a right triangle. Okay, so in other words, you must have a right triangle in order to have a hypotenuse. Okay, so if you don't have a right angle, then you cannot use this theorem. Mark that, highlight it, do something to tell you that. You must have a right triangle in order to use this theorem. That's not to say that right triangles can only use this theorem. Right triangles can use any theorem they want. But this theorem only works for right triangles. Okay, so in this diagram, we're shown that we have a right angle here and we have a right angle here. Okay, so we can use this theorem. It says if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So the hypotenuse of this triangle and the hypotenuse of this triangle, which is what I just highlighted, remember it is opposite of the right angle. Those have to be congruent. So I know if BC is congruent to EF, and guys, I just need to know one of the two other legs. It doesn't matter. It can be, let's say it's DF and AC. It could also be BA and ED. That would be okay too. And AC is congruent to DF. I'm going to say if both of these happens, then it follows that triangle CAB is congruent to triangle FDE. All right, so there's two theorems that people sometimes try to use that are not a thing, okay? That is the angle, angle, angle congruent theorem, okay? So think, if each of these angles are 60 degrees and each of these angles are 60 degrees, that doesn't mean the triangles are the same size. You can have equiangular triangles of various sizes, okay? And also, the side-side angle theorem is not a thing. Here's an example. The green sides are congruent. The yellow sides are congruent. the red angles are congruent, but clearly these triangles are not congruent. So don't use either one of them. Angle, angle, angle is kind of easy to remember. The way I remember this is because if you spell this backwards, it says a bad word. Okay, so don't write bad words backwards on your paper. It's not a theorem, it doesn't work. All right, guys, so this worksheet number 2 is your assignment for today, and I'm going to do a first few with you, or a couple from each section with you. So this first part, the directions say determine what type of information is given to you. Side, 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 angle, side, angle, angle, side, or hypotenuse leg. Okay, so I'm going to go and I'm going to highlight what we know. So I know this side, I know this side, and then I know this angle. Okay, so notice the angle is between the two sides. So I could say side, angle, side. The angle is between the two sides. Okay, over here, I know this angle, I know this angle, and I know this side over here. Now this side is not between the two angles. The side between the two angles would be this side. Okay, that's not the one we know. So this would be angle, angle side, and once again, the side is not between the two angles. All right, so you try to do 3 and 4 on your own, and then we'll go over them. All right, so on 3, you should have gotten angle, side, angle, and remember the side is between the two angles. And then on 4, you actually have this side, side angle, which if you remember, side, side angle is not a thing, so we could not use this. This is not a valid theorem. All right, so on these, we're going to look at both of these, and we're going to decide if they're congruent, and if they are, we're going to write a congruency statement. Okay, so I'm going to highlight the same things in the same color, T and E. So as you can see, I'm using the side angle side congruence theorem. And I can say that triangle PAT, and remember these have to go in order, so nothing purple, green, so nothing B, purple, B, and then green. All right, so same thing over here. If I highlight this and this, and then I highlight this the same color, and then I know that these angles are the same color. Now if I look at this, I notice I have a side-side angle, which is not a thing. So I cannot conclude these triangles are congruent with this information. So go ahead and do triangles 12 and 13 on your own. Let's assume they are congruent, and let's just say triangle PAT is congruent to whatever. Make sure the order matters. And then over here, we're going to say triangle PAT is congruent to whatever over here, and remember, order matters. So go through, figure out whether or not they are congruent. This is assuming they are, they may not be, what theorem you used, and then finish the congruency statement, and we'll go over it. All right, so this first one, so number 12, now they are congruent by the side, side, side congruence theorem. Notice all 3 sides of this is congruent to all 3 sides of the other one. And if I finish this congruency statement, I get triangle PAT is congruent to triangle BVE. Okay, and on 13, I have the angle side angle congruency theorem. Now notice the side is between the two angles, so it does have to be angle side angle. If you put angle angle side, that would be incorrect. And then triangle PAT is congruent to triangle VBE. All right, so now your homework is to finish the rest of this worksheet.